this is Scholar Strife doing some math today in geometry. We're going to be looking at the midsegment theorem and maybe some coordinate proofs. So first off, let's figure out what a midsegment is before we go to the midsegment theorem. So we got a triangle. Let's call this ABC. The midsegment, what it does, it connects two sides of the triangle. And what it does, it splits each side in half. So that side is congruent to that side, and that gets split in half as well. They don't have to be necessarily the same length, the left and right, but the left side is split in half and the right side is split in half. That is what a midsegment does. So the midsegment theorem, so the segment connecting the midpoints of two sides of any triangle is parallel to the third side and half as long as the third side. So what's going on is the midsegment MN is parallel, so same slope, as the third side, BC. As you can see, MN is parallel to BC there. And then also, this theorem says that the length of MN is equal to 1/2. So the midsegment is equal to 1/2 that base there, BC, or third side. Another way to look at it is 2 times MN is equal to BC, the length of BC. Okay. And then a coordinate proof is placing a figure in a convenient location on a coordinate plane so you can determine its side lengths. Usually you place it at the origin, so one of the vertexes, say if I'm doing a triangle, I would place the vertex on the origin there, and it just makes it easier for you to find the lengths of the triangle when using the distance formula. But here we go. Example 1. A large triangle window, also known as the Triforce, if you know anything about Nintendo, is segmented as shown. DF and EF are midsegments of triangle ABC. So DF splits these sides in half. Okay. So DF, let's use the black line here. And then let's use EF in blue. So if you rotate the triangle a little bit, and they say that EF is a midsegment, okay, that means this side here, it gets split in half, and this side here gets split in half. So however you look at it from the black perspective or the blue perspective, that's how that works. Find the lengths of DF and AB. Okay. DF and AB. So AB, so looking at the blue again, EF is the midsegment, and it's equal to 1/2 the length of the third side. So the blue two sides are the AC and BC. So AB is the third side. Okay. Or you can say 2 times EF is equal to AB. So 2 times 45 inches, because we know EF is 45 inches, is equal to AB. So AB equals 90. Alright, let's take a look at the black triangle. Or the black midsegment. So DF is parallel to BC. Okay. Maybe these colors will help you see what I'm doing here. So the blue lines are parallel and the black lines are parallel. So DF is equal to 1/2 BC. Since BC is 90, DF equals 1/2 of 90. So DF equals 45. And don't forget to put inches. Using example 1, consider triangle ADF. Okay, so we have ADF. That's that upper triangle there. We know that DF is 45. What is the length of the mid-segment opposite across from DF? So they're saying create a mid-segment here. So this is ADF. They're saying create a mid-segment. What's the length of that? Okay, so remember that mid-segment is half of 45. So 1/2 of 45 is equal to 22.5. Okay, so let me do that again. So we have ADF. We know that DF is 45 inches. And they want to create a mid-segment from here to here. So we want to know the length of that mid-segment. The length of mid-segment, as we know, is half the bottom there, or whatever it's parallel to. So 45 inches, half of that is 22.5. All right, in the diagram, QS is equal to SP, and PT is congruent to TR. Show that QR is parallel to ST. Okay? So because these two are equal, okay, that means because of that, that means ST is the mid-segment of triangle QPR. And since ST is a mid-segment, that means by the mid-segment theorem, QR, so therefore QR is parallel to ST by the mid-segment theorem. Because if ST is a mid-segment, it is parallel to the third side of the triangle, and it also splits the other two sides in half. And we've shown that they gave us the fact that it's split into two pieces there, those two sides. So just to highlight, ST splits QP and PR into two pieces. So it must be parallel to the third side by the midsegment theorem. Example 2. If V is a midpoint of QR, what do you know about SV? Okay. I'll do this one in blue. So V is a midpoint of QR. That means this side here is congruent to that side. That would also mean SV is a mid-segment, because we know that QP is already divided in half and PR is divided in half. So SV is a midsegment of triangle QPR. Alright. Place each figure in a convenient location on the coordinate plane. Label each vertex. So normally they would give you something to draw, but in this case, you always want to put one at the origin. One of the vertices, one of the corners. And a square has side lengths that are the same. I'm just going to choose 5. Or whatever this is. 1, 2, 3, 4, 5. So there we go. Square. This is 0, 0. This is 5, 0. This is 5, 5. This is 0, 5. And acute triangle. So once again, 0, 0. 3 sides this time. I don't know, like that. One, 2, 3, 0. Usually they give you some dimensions. And 1, 2, 1, 2, 3, 4, 5. So 2, 5. Alright. So the key thing is always put one of your corners at 0, 0. So whenever you have to use the distance formula to find the length of the side, it's easier. It's a lot easier on yourself when using the distance formula. Find the length of the diagonal and find the midpoint of the diagonal DB. Okay? So they give us variables for our coordinates. Okay? But we're still going to do the same thing here. Okay? So we want to find the length of the diagonal. So let's look for the length of DB. So remember the distance formula is x2 minus x1 squared plus y2 minus y1 squared. Okay? And I'm just going to call this one x2, y2, and x1, y1. And you're going to see that it's going to be a lot easier. Now, if we had numbers, we would just put the numbers in. But in this case, we have letters. So we got to put those in. So x2 is s, not 5, s, minus 0 squared plus s minus 0 squared. So it's just s squared plus s squared, which is 2s squared. Okay. And this would simplify to s times the square root of 2. Now, that's the length. And that's the length of any diagonal of a square. If you knew the side length, you just times it by the square root of 2. And that's your diagonal. The midpoint, so remember, midpoint formula is x1 plus x2 divided by 2. That'll give you your x-coordinate, and then your y-coordinate is y1 plus y2 divided by 2. And that would be your y-coordinate. So if I translate this, this would be 0 plus s divided by 2, 0 plus s divided by 2. Again, I'm not writing 5, I'm writing s. So this is s divided by 2, s divided by 2. Okay, checkpoint 3. Now find the length of diagonal AC. What do you notice? Why this is true for all squares. So if you do the same thing, diagonal AC, you'll get s minus 0 again, plus 0 minus s squared, which is equal to s squared plus a negative s squared, which is still a positive s squared. So you'll get the square root of 2s squared again, which is s times the square root of 2. Diagonals are congruent in a square. And that's that.